Hello students, നമുക്ക് കണ്ടിന്യൂ ചെയ്യാം. ഫൊമിനിയസ് തിയറം സെക്കൻഡ് ഫോം. നിങ്ങൾ ഫസ്റ്റ് ഫോം കണ്ടു കഴിഞ്ഞു. ഫസ്റ്റ് ഫോം ദാറ്റ് വാസ് ടിപ്പിക്കലി ഫോർ ഫങ്ഷൻസ് ഡിഫൈൻഡ് ഓവർ എ rectangular region. Here our region need not be a rectangular region. So suppose our region is of a special type but not a rectangular region. Suppose this is the region R. So here this curve that is continuous, it's a function of x, so call it y is equal to, let us say, g1 of x, and this curve that is another continuous function of x, so call it as y is equal to g2 of x, and here x varies from a to b. So R is defined by g1 of x less than or equal to y less than or equal to g2 of x, where both g1 and g2 are continuous, and x varies from a to b, a less than or equal to x less than or equal to b. This is one region under consideration. Okay, we can have another region. So it is, let us say, something like this. So R may be of this form. So this is a continuous function of y. This is another continuous function of y. So call this as, let us say, x is equal to h1 of y, and this is x is equal to h2 of y. And y varies from, let us say, c to d. Y varies from c to d. So my region R would be like this. R is equal to, R is defined as h1 of y less than or equal to x less than or equal to h2 of y, where both h1 and h2 are continuous functions of y, and y varies from c to d, and y varies from c to d, c less than or equal to y less than or equal to d. So either R is of this form or R is of this form. Then double integral over R. So Fubini's theorem says double integral over this R, call it R1. This is R2. So this is R1, this is R2. Fubini's theorem says that the double integral of f of x comma y can be calculated as iterated integrals. So first integrate with respect to y. Y varies from g1 of x to g2 of x. Your function f of x comma y, integration with respect to y dy, keeping x fixed. Then you integrate the expression x varies from a to b dx. Or this, or double integral over R2, this region R2, f of x comma y dA can be evaluated again as iterated integrals. How? First you integrate in this case with respect to x first. X varies from h1y to h2y. X varies from h1 of y to to h2 of y, your f of x comma y dx, keeping y fixed. Okay, then you integrate this expression, which is a function of y now. So you integrate that expression with respect to y. Y varies from c to d dy. So Fubini's theorem says this. We will do one or two examples. I will not erase this portion and this and this. The remaining I will erase. So this is Fubini's theorem. This is Fubini's theorem, Ft. So example, find the volume of the prism whose base is the triangle in the xy plane bounded by the x-axis the lines y equal to x and x equal to 1 and whose top lies in the plane z is equal to f of x comma y equal to 3 minus x minus y. So this is the problem. So how do you do this? So first let us plot the region R. So it's given to be a triangle. What is the triangle? Triangle in the xy plane. In the xy plane bounded by the x-axis. This is the x-axis. The lines y is equal to x and x equal to 1. So this is y equal to x and this is x is equal to 1. So this is the region R. And now you have to find the volume of the prism. So remember, double integral, it represents the volume of the surface bounded by, or the volume of the surface that lies vertically above the region R. Double integral represents volume of the surface that represents that lies vertically above the region R. So you have to find the volume of this surface. So this is a plane. F of x comma y equal to 3 minus x minus y is a plane. So how that plane will look like? So assume we have a z axis. Just a second. Yeah, suppose this is the z axis. So you have a plane you have a plane like this. You have a plane like this. And look at the volume that is bounded by this plane that lies vertically above the domain R. So you have to find that volume. That is the problem. So you can use Fubini's theorem. So using Fubini's theorem, how do I do? So let us use this form. So let me erase this form. Or let us use this form. I will erase this form. So this is the Fubini's theorem I am going to use. So double integral over R 3 minus x minus y, that is the volume, dA equal to, by Fubini's theorem, first integrate with respect to x. X varies from where to where. So you have to integrate what? You have to integrate your function f of x comma y equal to 3 minus x minus y with respect to x, keeping y fixed, right? So you have to determine what are the limits of integration. What are the x limits of integration? So x varies from here to here. X varies from here to here. So this is x equal to y and this is x equal to 1. So x varies from y to 1, f of x comma y dx, keeping y fixed. When you evaluate this, you will get a function of y and integrate that function of y with respect to y. So y varies from where to where? Y varies from 0 to 1. Y varies from 0 to 1. This is the point 1 comma 1. This is 0 0. This is 1 0. This is 0 1. So y varies from 0 to 1. dy. This is what you are supposed to do. Okay, so let us evaluate this. How do I evaluate this? So let me remove this portion. So here I have to perform this integration first with respect to x, keeping y fixed. So integral y varies from 0 to 1, integration with respect to x. So 3x minus x square by 2 minus yx between the limits x equal to y to x equal to 1, then dy. So this is equal to integral y running from 0 to 1. So put x equal to y here in the lower limit, and in the upper limit you have to put x is equal to 1. So what I will get? 3 minus 1 by 2 minus y minus, now put x is equal to y in the lower limit. So what I will get? 3y minus y square by 2 minus y square, then dy. So what I will get? Let me remove this question. So this is equal to 3 minus 1 by 2 is 3 by 2, sorry, 5 by 2, integral 0 to 1, 5 by 2 minus y plus 3y it is no minus y minus 3y minus 4y plus y square by 2 plus y square. So it is 3y to y square dy. This is equal to integral 0 to 1 5 by 2y minus 4 into y square by 2 plus 3 by 2 into y cube by 3. Okay, so you have to substitute the limits. Y is equal to 0 to 1. So what I will get? 5 by 2 minus 4 by 2 is 2 plus 1 by 2, and in the lower limit you will get 0. So, and what is the answer? 5 by 2 plus 1 by 2 is 3. 3 minus 2 is 1. So the answer is 1. This is one way of looking at this problem. Okay, you can use the other form of Frobenius theorem. So what is that? So here what did I do? I integrated with respect to x first and then with respect to y. Let me change the order of integration. So what I will get? Or I can integrate with respect to y first, then with respect to x second. So how do I take the limits of integration? So here y varies first. So y varies from, so what is this line? X-axis is y equal to 0. X-axis is y equal to 0 and this is the line y equal to x. So y varies from 0 to x and x varies from 0 to 1. X varies from 0 to 1. 3 minus x minus y. Integration with respect to y first, then with respect to x. I have changed the order of integration. So this is equal to, first we have to compute the integration with respect to y. So this is x equal to 0 to 1. 3x minus x square by 2 minus yx. So here y is assumed to be, we are integrating with respect to y. So 3y minus, keeping x constant. So minus xy minus y square by 2. Y varies from 0 to x, then integrate with respect, so keeping x fixed, so the whole expression is going to be a function of x. So dx, this is equal to integral x is equal to 0 to 1. So substitute y is equal to x here. So 3x minus x square minus x square by 2, put y is equal to x, and in the lower limit y is equal to 0, so minus 0 dx. So what is going to be the answer? So let me do it on the other side. So this is equal to, now I have to integrate with respect to x. So 3 into x square by 2 minus x cube by 3 minus x cube divided by 6 between 0 to 1. So what I will get? 3 by 2 minus 1 by 3 minus 1 by 6 This is equal to 3 by 2 minus, what is 1 by 3 plus 1 by 6? LCM is 6. 6 by 3, 2. 2 minus 1, right? So this is 3 by 2 minus 1 by 6. So what is this? Again LCM is 6. 6 by 2 is 3. 3 into 3 is 9 minus, oh, it is mistaken somewhere. So what about the LCM here? It is 6. 6 by 3 is 2. 2 minus 1. So 3 by 2 minus 1 by 6. So 6 by 2 is 3. 3 into 3 9 minus 8 by 6 cannot be the answer. You should get this answer because both represents the double integral. So I think somewhere six by 3 is, oh, I think here it is plus because it is minus of this plus this. So it is plus, yes. So 3 by 2 minus 3 by 6. 3 by 6 means 1 by 2. So 3 by 2 minus 1 by 2 is, yes, 1. You are getting this answer. So Fubini's theorem is used in two different ways to calculate the required volume. Thank you.